Hi friends, so the basic foundation of parabola has been built till now, and now the journey begins for the IIT-JEE. So here in this part we are going to start with lines and parabola and position of a point with respect to parabola. Again, the lines and parabola will form the key center for the JEE mains and advanced, and in this part we are going to start from the basics of that and we will take that forward in the coming parts. So let's start this part. Position of a point with respect to parabola. So let us consider a parabola y square equal to 4x as shown in the figure, okay. So we are going to see, if I draw it here, we are going to see that whether a point is inside, on, outside. Inside means, interior means within the boundaries, the closed thing, okay, this parabola, okay, and on means the satisfying, which is satisfying the parabola. And exterior means we will see in terms of the distance that for satisfying the parabola clearly we need to check. We will put y1 here, LHS, and we will see this is LHS and we will compare it with the RHS. So clearly both are equal, then the point lies on the parabola. Now if I write, suppose if you take any point x1 comma y1, okay, so a point on the parabola will be corresponding to this x1, okay, so that will be 4ax1 if we are talking about x1 and comma this is y square, okay, that will be of that form, okay. If I make it y, it will be under root, so that is not a worry to us. So now we are going to see, we are going to compare y1 square with this value. So if it is equal to 4ax1, it means the point is on the parabola. If this value is greater than 4ax1, means for the given x, suppose if you take a point x1 y1 here as shown, so this will be x1, corresponding to it we will have 4ax1 and this will be y1 square. So corresponding to this, what we are going to do, we are having this y1 square greater than 4ax1. So this means this point lies outside the parabola. Similarly for inside, the condition is y1 square lies somewhere here. So that should be less than this quantity. So easy to understand. You can interpret and also use this notation for understanding it betterly, okay. So moving on to the lines in parabola. Now we have done point and a parabola. Now let us see what happens when we take line and a parabola. So in this figure, this is a parabola, you can clearly see, okay, and I have drawn three lines with respect to it. One which is intersecting at 2 points, this is intersecting it at or touching it at 1 point, and this is not touching parabola at all. So three cases are there, okay. So if this is the equation of parabola and this is the equation of line. So by solving this line with the parabola and applying the condition of roots, we can see that whether the given line is tangent, which is touching at 1 point, whether it will be forming a chord or intersecting at 2 points, or it will be do not touching at all, okay. So what we can do, solve this by putting it here y square as done in this. So you will get a quadratic. Now at most it can have two roots, means at most two roots means that if we are putting d greater than 0, we will be getting condition for this. If we are putting it equal to 0, we will be having the condition of tangency only one root, and d less than 0, we will be having only no touching, okay, this third case. So let us see that on solving the equation, now this is the discriminant, okay, for the given equation. The equation, this mx square plus x into 2mc minus 4a plus c square, for that we are getting this as the discriminant. Now based on the conditions which I mentioned, we will get the conditions, okay. So the concept will be more clear once we see the question based on this concept, okay. So let's see a question based on this. So it says prove that the line Lx plus My, a very generalized question, okay, will touch the parabola this. So this is the condition we are like gonna confirm. So let us consider this parabola, okay, and we want that it should touch, okay, this general line at one point. So again what I'll do, I'll write y is equal to n minus Lx over m. Now I will solve this with this equation by substituting y here. So this strategy we are going to follow everywhere, means whether you are doing conic sections, any conic, circle, parabola, ellipse. So this technique for a line to become a tangent, you always need to do this thing. Although we could have done by using that, we could have first converted it in that way and find the condition according to that, but we are going to, I'm showing it again so that you remember it, okay. So this will be n square plus l square x square minus 2 nlx, and m square I'll take here, 4am square x. So now when I take x square on one side, okay, this will be l square x square. Now from here I am taking x common, minus x common, so it will be 2nl, and when I'll bring it on this side I will be left with 4am square. Now this is the remaining term, n square equal to 0. Now again what we will do for touching, the condition is d should be equal to 0, okay. So for that this will be 2nl minus 4am square whole square minus 4n square l square, okay. So this will be equal to 0. Now on solving this, what we will get, 4n square l square, this will be plus 16a square m4 minus 4 into 2 into 2, 16 a m square nl minus 4n square l square equal to 0. This will get cancelled with this. So we are left with a square m4 is equal to a m square nl. So if I take it on this side, we'll get the condition. So if it would have been asked that prove that the line, this will, what, find the condition for this to intersect the parabola, then we would have put this greater than 0. If it is not intersecting, less than 0. So according to the condition we can find according to the appropriate number of roots and satisfy the given condition. So this is very useful thing while we are doing lines and any conic line, interaction of line. So we are always gonna solve it using that. We are substituting one variable in a conic and then we will check for the number of roots. So we have learnt the position of point with respect to parabola. That was quite easy, and we have also seen what are the possibilities of a line which can either touch, intersect or do not touch the parabola. We have also done questions based on that, and I hope that it was quite clear. In the next part we are going to start from tangents and normal. That is again the most important topic, okay. So lines, it was just an introduction. Now how we will use the condition of tangencies, the intersection, that we will see in the next part. Stay tuned for that.